Okay, tough concept, and there's a couple I want you to try dealing with proofs. So in this one, I want to use the dot product to prove the cosine law. So what are we required to prove? RTP. We want to prove that c squared equals a squared plus b squared minus 2ab cos c. So that's what we're looking at trying to prove. So I'm going to call these vectors a and b. And I'm going to call that vector C. So, tricky part here. And it's tricky because when you haven't had experience with the proofs, I only have you do a couple, and I try to pick some of the ones that are more tangible, I would say, for your starting point. But it is important for those going into university that you do look at a couple of the proofs. So where do you start with this? Well, in this case, we're starting with this c squared. So in terms of vectors, what does it look like? It looks like the magnitude of c squared. That's our starting point. How do you get magnitude of c squared? What is that equal to? Well, we talked about vector properties, and you can get the magnitude of c squared if you look back at vector properties by doing the dot product of a vector on itself. So c dot c gives you the magnitude of c squared. Now, what I'm going to do, the given information here, I'll put angle C there. The given information is this is vector C, but I want to write it in terms of A and B because it's the information that's involved here. So what does vector C equal? Well, vector C, tail's there, head's at the top. So to get from tail to head, you would have to go negative A plus B. All right, or we could write that as vector b minus a. So we now know what c is, which allows us to return to our proof. So the magnitude of c squared, I'm going to replace vector c with b minus a dot b minus a. And now, I've already said that our algebra rules hold true, so we are going to have to use distributive law here. So that means I'm going to have b dot b, so that's the magnitude of b squared, minus a dot b, or b dot a, minus a dot b, plus the magnitude of a squared. So cleaning that up, magnitude of a squared plus magnitude of b squared. Remember, we talked about dot product. Order does not matter. So b dot a and a dot b are actually like terms. So we're doing some subtraction. So 2 multiplied by a dot b. And now, how do we make that final jump? Off to the side here. If you recall, the dot product of two vectors is the magnitude of a, magnitude of b cos theta. So using that, we finish off with what looks like our cosine law. So therefore, QED, quantum demonstrats. Okay, so that's just using vectors to do a proof. So the ones you're going to try, similar or easier difficulty, but they're all going to seem hard because you don't have much experience with proofs, so keep that in mind. I'll definitely be giving you a hand getting through that. Okay, determine torque for the following. The diagram, I got to be careful here. Here's the applied force, okay, and what I got to do, I got to put a couple of numbers on here. So let's go with 2, and that looks like about the same, 2, and let's make this a 3. And that vector there, I'll just change the color. This is the applied force. Okay, so that's the force, and the black is actually the wrench. So this is the wrench. Here's the pivot here. The pivot, and here's my wrench. So, in order to solve this question, what is actually your lever arm here? What is actually your lever arm? Well, your lever arm is from pivot to point of application, and it's the direct point of application. So there is the lever arm. So we need to find the length of that lever arm. So using right angle triangles, I know that this base of the triangle has a length of 5. It has a height of 2. So we're going to have to use Pythagorean theorem to find the magnitude of AB, or length, whatever variable you're going to apply here. So the magnitude of AB would be 5 squared plus 2 squared. So it's the square root of 29. All right. So we have the magnitude. I'm going to give you a value of F. So magnitude of F, let's keep it easy, 10 newtons. And we need an angle theta. So we're looking for that angle theta. So we have opposite and we have adjacent. So that means we're going to use tan. So tan inverse of opposite over adjacent. So 2/5. So there is our angle. So therefore, torque is equal to magnitude of F, magnitude of AB, sine theta, n. So we know that the force is 10. We know the magnitude of the length of the lever arm is square root of 29. And the angle, sine theta, is tan inverse of 2/5. And I'm going to need to add a direction here. So again, I'm going to use my hand. So I'm pointing my fingers along the lever arm. So there's my fingers. I got to make sure that they're curling, or the middle finger is pointing the direction of force. So I find that I'm turning it lefty-loosey, and we find that we have the torque is out of board. So there's my direction. Okay, so the force is coming out at you. So again, that's using your right hand rule. So there you go. That's how you'd calculate torque. The big thing there is remembering that the lever arm is the direct distance, not the crooked path. All right? And finally, here are the proofs that I want you to try. There are 4 proofs there for you to try on your own. They're going to be some you're going to find easier than the others. So I want you to try those 4. And here is the assigned homework associated with applications out of the textbook. So if you want to work your way through that. And finally, we got a couple of things coming up. There's a unit test coming up. The test date I'll let you know in class. Review material will be up on the website, and that you'll find on website. And then what I have from the textbook are a couple of review pages that you can pick and choose your way through. But again, primary source of studying for this course should be homework, making sure the homework is complete and understood. And then the second part of that is getting through the review itself. So if you have any questions, please make sure you see me in class. And again, please make sure you try some of these proofs. You should actually do all the proofs, because I will put one in the thinking category for you to work on a test. All right. Good luck on the first unit.